This is a linear function. The parent function name is y equals x. The equation of the function is y equals x. This is the graph of y equals x. The domain of the function is negative infinity to infinity. The range of our function is negative infinity to infinity. The symmetry of our function is odd.
Our function is not bounded. There are no extrema, and there are no asymptotes.
There are no discontinuities in our graph. As x values approach y negative infinity, y values also approach negative infinity. As x values approach infinity, y values also approach infinity. The function continually increases.
This is a quadratic function. The parent function name is y equals x squared. The equation of our function is y equals x squared. This is the graph of y equals x squared. The domain of our function is negative infinity to infinity. The range of our function is 0 to infinity. The symmetry of our function is even.
Our function is bounded below. There is an absolute minimum of 0 at x equals 0. There are no asymptotes.
There are no discontinuities in our graph. There is a limit of infinity on y as x approaches to infinity. There is a limit of y as infinity as x approaches negative infinity. Our function decreases from negative infinity to 0 and increases from 0 to infinity.
This function is called the cubic function and is also known as the cubing function. The parent function is f of x equals x to the third power.
The domain and range of a cubic function is the set of all real numbers.
For symmetry, this function is symmetric with respect to the origin, which means that this function is an odd function. If you plug negative x into it, you'll get negative x cubed, the opposite of x cubed. For boundedness, there's no boundedness to this function. There are no vertical or horizontal asymptotes, and there are no discontinuities because this function can be drawn entirely without lifting your pencil, which means that it's continuous.
There is no decreasing because going from left to right, the y value is steadily increasing to all real numbers. The extrema of f of x equals x cubed is none because there is no local minimum and maximum or absolute maximum and minimum. This is the end behavior. As x approaches negative infinity, the limit is f of x equals negative infinity, and as x approaches infinity, the limit is f of x equals infinity.
Okay, so our function is the inverse function. It's also known as a rational function or reciprocal. For our function, the parent function is f of x is equal to 1 over x.
The domain of our function is negative infinity to 0, union 0 to infinity, and the range is the same.
Our symmetry is odd, and our function has no bounds.
Our function's continuity, it has an infinite discontinuity, and it's not removable at x equals 0.
We have no extrema. There is no horizontal asymptote at y equals 0, and a vertical asymptote at x equals 0.
And for the end behavior, when f of x is approaching infinity, it is 0, and when f of x is approaching negative infinity, it's also 0.
We have the square root function. The function is f of x is equal to the square root of x. The domain is 0 to infinity, and the range is 0 to infinity. This graph has no discontinuities and is continuous.
The graph increases from 0 to infinity. It does not decrease at any time. There is an absolute minimum of 0 at 0.
The function does not have symmetry, and it is bounded below.
The function has no asymptotes. As x goes to infinity, the limit is infinity, and as x goes to negative infinity, the limit does not exist.
One of our functions were exponential growth. Exponential growth occurs when b is greater than 1 and x is, an example is when y equals 2 to the power of x. The domain is negative infinity to infinity and the range is 0 to infinity. Exponential growth has no symmetry. It is bounded below and not above. The horizontal asymptote is y equals 0 and it does not have a vertical asymptote. It is continuous and increases from negative infinity to infinity and it does not decrease. It has no extrema. For the end behavior, the limit for x to negative infinity is f of x is equal to 0. And for x to infinity, the limit is f of x equals infinity.
We also had exponential decay. It occurs when b is greater than 0 but less than 1. An example is y equals half of x, 1/2 to the x power. The domain is negative infinity to infinity. The range is 0 to infinity. Exponential decay functions have no symmetry. They are bounded below but not above. They have a horizontal asymptote at y equals 0. There are no vertical asymptotes. They are continuous. They do not increase. They decrease from negative infinity to infinity. There are no extrema. The end behavior is from x to negative infinity, the limit is infinity, and from x to infinity, the limit is 0.
Now next up, we have the logarithmic function. The parent function is f of x equals log 2 of x. The domain is 0 to infinity, not including 0. The range is negative infinity to positive infinity. It does not have symmetry, and it is not bounded. It has a vertical asymptote at x equals 0. It does not have any discontinuities. The logarithmic function increases from 0 to infinity, not including 0, and it does not decrease. There are also no extrema. The limit of f of x as x approaches infinity is infinity. The limit of f of x as x approaches negative of infinity does not exist.
This is an analysis of the absolute value parent function. The parent function is f of x equals the absolute value of x. And here you can see our beautifully drawn graph. The symmetry is even, it is bounded below, and there are no asymptotes or discontinuities.
It's increasing from 0 to infinity and decreasing from negative infinity to 0. It has an absolute minimum of 0 at x equals 0. The limit of f of x equals infinity as x approaches infinity. The limit of f of x equals negative infinity as x approaches negative infinity. The domain is negative infinity to infinity, and the range is 0 to infinity.
This is an analysis of the greatest integer function, also called the step or floor function. The parent function is f of x equals the greatest integer less than or equal to x. Here is our fabulously drawn graph. Every y value is an integer, so if x equals 2.6, y would equal 2. There is no symmetry, it is not bounded, and there are no asymptotes. There are jump discontinuities at each integer.
It is constant at each step, and there are no extrema. The limit of f of x equals negative infinity as x approaches negative infinity. The limit of f of x equals positive infinity as x approaches positive infinity. The domain is negative infinity to positive infinity, and the range is all integers. And remember to have fun.
So we had the logistic function. The equation for the logistic function is f of x equals 1 over 1 plus e to the negative x. This is what it looks like when it's graphed. These are the asymptotes, and that is the y-intercept. The domain for this function is negative infinity, positive infinity, or all real x values. The range of this function is 0, 1 due to the asymptotes.
The logistic function has no symmetry. It is neither even nor odd. If negative x is put into the equation, it does not form f of x or the opposite of f of x. The function is bound above and below. The horizontal asymptotes keep the y values between 0 and 1. It cannot go infinitely up or down.
The horizontal asymptotes of this function are y equals 1 and y equals 0, and there are no vertical asymptotes. There are no discontinuities. This function is increasing from negative infinity to infinity and does not decrease.
Regarding extrema, there is no local or absolute maximum or minimum. Regarding end behavior, as x approaches negative infinity, the y value approaches 0, and as x approaches infinity, the y value approaches 1.
Our first function is the sine function. The equation is f of x equals sine of x. This is the graph. You'll notice that the x values are in terms of pi. The domain is negative infinity to infinity, and the range is negative 1 to 1, including both numbers. This function has odd symmetry.
The sine graph is bounded below and above. There is a local maximum of 1 at x equals 1/2 pi plus 2 pi k. K is an element of all integers. There is a local minimum of negative 1 at x equals 1.5 pi plus 2 pi k. There are no asymptotes and no discontinuity. The end behavior doesn't exist. The function oscillates between increasing and decreasing.
Our second function is the cosine function. The equation for this one is y equals cosine of x, and the x values of this graph also are in units of pi. The domain is negative infinity to infinity, and the range is negative 1 to 1, and it includes both numbers, and it has even symmetry.
The cosine function is bounded above and below. There's a local maximum of 1 at x equals 0 plus 2 pi k. There's a local minimum of negative 1 at x equals pi plus 2 pi k. Once again, k is an element of all integers. There are no asymptotes and no discontinuities. The end behavior doesn't exist, and the function oscillates between increasing and decreasing as well.